Good morning. This is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today, in this lecture, we are going to discuss about the procedure about the testing of hypothesis. So, before going to know the procedure for testing of hypothesis, we should know the basic definitions about the population, sample, large sample, small samples, and what are the type 1 and type 2 errors. So we discuss about all this in this lecture. So the first one is population. Population is a finite or infinite number of collection of objects, and a sample is a subset of the population. For example, the population in India and the population in Hyderabad. So here the population in India is a population that is a finite or infinite number of pupil, and pupil in Hyderabad is a subset of the population. So that's why this Hyderabad pupil are called sample and the pupil in India is called population. So subset of the population is called sample. So in this sample we have large sample and small sample. So what is large sample and a small sample? Here if we take the number of objects is denoted by n. If it is greater than 30, then it is large sample. If n value is less than or equal to 30, is small sample. That means a sample consists of less than or equal to 30 objects is called a small sample. If the collection of objects in that sample consists of greater than 30 is called a large sample. So, in testing of hypothesis, the sampling theory plays very important role. Based on the sampling theory only, we give the conclusion about the acceptance or rejection of the hypothesis. So, we calculate the statistical measures, mean, standard deviation and variance. These statistical measures we calculate in population as well as in sample also. But the notations are different in population and sample. So the mean is denoted by mu in population and in sample it is denoted by x bar. Mean or average, both are same. Standard deviation is also a statistical measure and which is denoted by sigma in population and S in sample. Variance is also a statistical measure which is denoted by sigma square in population and S square in sample. That means standard deviation is square root of the variance. So these are the statistical measures in population and sample. But the formulas are same to calculate the mean, standard deviation or variance. So here mean or average is summation xi by n. That means here n is a number of observations and summation xi is sum of the observations. So sum of the observations by number of observations is average of that sample or the population. But here the notations are very important whether we are calculating these statistical measures in populations we are calculating or in sample we are calculating. And sigma square, this is variance. The formula is 1 by n minus 1 into summation xi minus x bar whole square. So this is sum of the squares of the mean deviations and n is the number of observations in that sample or population. Now what is a hypothesis? Hypothesis means it is a statement or it's a claim about the population parameter. So population statistical measures are called parameters and sample statistical measures are called statistic. So here always we give the hypothesis is a guess or claim or statement about the population parameter. So this is very, very important. So in this procedure, the first step is what you are claiming about the population parameter. That means here the statistical measure we can take it as mu or sigma square or sigma. Suppose I want to give a guess or a statement or my claim about the population parameter. Here I am considering the population is a class of students consists of 70 or 100 students. 100 students is the population. So in this class, I am claiming that the mean or average mark of this class is mu equal to 60. 60 marks is the average mark of this class. This is my claim. So the claim or statement is called hypothesis and it is denoted by H0 and it is called as null hypothesis. So here null hypothesis is acceptance or rejection of a null hypothesis and it is usually denoted by H0. So here my claim or statement about the population parameter mu equal to 60 is my claim. Now I want to test whether to accept or the reject about the claim. Then we take the sample in this population. Then we give the conclusion about the acceptance or rejection of the null hypothesis. So the second step is alternative hypothesis. Suppose based on the sampling theory, we are accepting a null hypothesis H0 mu equal to 60. Then we give the conclusion, we accept the null hypothesis H0 mu equal to 60 is the average mark of the class and this conclusion is given based on the sampling study. Suppose here we are rejecting this hypothesis, then we take the alternative hypothesis H1 denoted by H1 and it is defined as either mu greater than 60 or mu less than 60 or mu not equal to 60. These are the three different cases we define in alternative hypothesis. So here, if we are rejecting null hypothesis H0 means we are accepting alternative hypothesis H1 either mu greater than 60 or less than 60 or not equal to 60. That means the mean average mark is not 60 marks, maybe greater than 60 or less than 60. So that's why we can define alternative hypothesis H1 in three ways, that is greater than 60, less than or not equal. So these two greater than and less than are called one-tail test. One-tail test and not equal to is called two-tail test. Here mu not equal to mu naught, mu greater than mu naught, mu less than mu naught. So this not equal to is called two-tail test and greater than is right-tail test and less than is left-tail test. So what is here a two-tail test, a right-tail test and left-tail test? Suppose we take a normal curve bell-shaped curve. In this is mu, which is equal to mu naught. Here, I claimed that mu equal to 60 is the average mark of that particular class. If it is not equal to 60, then, so here my claim is, I am giving with a 95% confidence interval, confidence limits. So at what confidence I am giving this claim means, that is based on sampling theory. So here I am giving the claim that mu equal to 60 or the average mark of that particular class is 60 with a 95% confidence I am giving this conclusion. So here 95% confidence means remaining 5% may be error. So that error is divided into two parts, on left tail of mean and right tail of mean. And this error is denoted by alpha, and which is called as level of significance. So level of significance is the error in my claim. Remaining 95% I am with confidence I have given this claim. Remaining 5% alpha, that is 5% is the error in my claim. So that alpha is divided into two equal parts, that is a two-tail test. If the total error is divided into two equal parts, then that is denoted by alpha by 2 and alpha by 2. Half part is left of the mean and remaining half is right of the mean. So the 5% is alpha. Alpha by 2 means 0.025. This is alpha by 2. Similarly, on the right of mean also 0.025. So this is alpha by 2. Now this area is called rejection region. And this region is called 1 minus alpha. This is acceptance region. Acceptance region. So this 95% is the acceptance region. Remaining 5% is the rejection region. Suppose we divide the total error into two equal parts, alpha by 2 to the left of the mean and alpha by 2 to the right of the mean, then that is called two-tail test. Suppose we take the total error on either side of the mean. Suppose alpha equal to 5%, that is 0.05. Here I am taking the total error to the right of mean. So this area is called rejection region and this area is called acceptance region. So this is 1 minus alpha now. This is alpha, 0.05. So this right-tailed error is called right-tail test. That means here we are taking the total error to the right of mean is right-tail test. If it is taken to the left of mean, then that is left-tail test. That means here greater than and less than are called one-tail test. That means the error is denoted on either side of the mean, not on both sides. Then that type of test is called one-tail test. One-tail test. And this is two-tail test, since the total error is divided into two equal parts. So this is the difference between a one-tailed and a two-tailed test. So this is a level of significance alpha. We can take either 1%, 5%, 10% error in our claim. Remaining is 1 minus alpha is the acceptance region or confidence limit in our claim. So next, based on the large sample or small sample, we apply appropriate test statistic or formula to give the conclusion about the claim. Conclusion about the claim means whether you are accepting or rejecting your claim. That is based on the test statistic which you are taken from the sample. Suppose for all large samples, n greater than 30, we apply z-test. And the test statistic we are calculating from the sample data is z calculated value. And we take z tabular value also for this 1%, 5% and 10% level of significance. So what is the tabular value? And we calculated for z test is the calculated value. We compare both the calculated value and tabular value. If our calculated value is less than tabular value, then we accept our claim. Otherwise, we reject the claim. That means calculated value is greater than tabular value, we reject our claim. So this is the testing of hypothesis. So the first step is null hypothesis, H0, which is our claim about the population parameter mu equal to mu naught. Second step is alternative hypothesis, which is denoted by H1. It can be defined in three ways: mu not equal to mu naught, or mu greater than mu naught, or mu less than mu naught. And level of significance. Third step is level of significance, which is denoted by alpha. That means in our claim at what percentage there may be error. So that error is denoted by alpha, which may be 1% or 5% or 10%. Generally, we take this much error percentage we take and we test the hypothesis. And fourth step is based on the sample data, we apply appropriate test statistic or formula, that is a test statistic. This calculated value is only for sample data. Based on the sample data, we apply test statistic. And the last step is we give the conclusion. Conclusion is what is our z calculated value and what is the tabular value based on the error percentage, and we compare both calculated value and tabular value. If calculated value is less than tabular value, we accept our null hypothesis H0 or we accept our claim. What about what we have given the claim about the population parameter, or if z calculated value is greater than tabular value, then we reject null hypothesis. Obviously, we are accepting alternative hypothesis. This is about the testing of hypothesis based on sample data. Now type 1 error. What is type 1 error? Suppose here I am giving an example. A bag contains 25 kgs rice. Whether we have to accept this bag or not, that is depending on the sample rice. So suppose the sample rice is not good. Suppose the sample rice is not good, then we are rejecting a big lot 25 kgs bag. That means we are rejecting a good lot 25 kgs bag even though a sample rice is good. So this type of error is called type 1 error. And type 2 error is we are accepting a good lot even though the sample rice is not good. So here this type of error is called type 2 error. So type 1 error is producer's risk. This type of error is called producer's risk and it is denoted by alpha error. That means even though the sample rice is good, we are rejecting a big or a good lot 25 kgs or 50 kgs bag. So 25 kgs or 50 kgs bag is rejected based on the sample rice. So that type of error is called producer's risk or it is denoted by alpha error. Even though the sample is not good, we are accepting a good lot or a big lot. That means that is a type 2 error and it is a consumer's risk. Consumer's risk. And it is denoted by beta error. So these two errors generally we study in sampling theory. So in this lecture, we have discussed about the procedure of testing of hypothesis and also type 1 and type 2 errors. Thank you.